All right, here we go. Section 6.4. Title is Use Inverse Functions. So two vocabulary, which are pretty interchangeable. Well, not interchangeable, I guess quite different in a way, but they're either the inverse relation, and we define that as a relation that interchanges the input and the output values of the original relation. So you might, on the side here, write, we switch x and y. So you take an equation and you would switch what, let's say you had an equation that said y is equal to 2x plus 3. And if you wanted to find the inverse relation, you would switch the x and the y. Pretty awesome. The inverse function, well, that's exactly the key here is it a function? Is the inverse also a function, or is the original a function? So the original relation and its inverse relation were both functions. Oh, excuse me. Get a drink of water. Actually, I think I'm all right. All right, here we go. Example 1. Find the inverse relation. So just similar to what we just did, here you have a line, and this guy is, the original here, this line is a function, even though they present it as y equal to. Let's just keep calling it a relation. So to do the inverse, we switch x with y. So simply x where you saw y, and y where you saw an x. So sorry about that. It looks like a z, but that is a 7. And now you could say, hey, I'm done, but the standard way to present relations or functions is to set them equal to y. So here we would add 4 to both sides and get x plus 4 is equal to 7y. And then finally we would divide both sides by 7, and our inverse would be y is equal to 1/7 x plus 4/7. Nice, and you've done it. You have now figured out the inverse relation for this original. This is the original, and this is its inverse. So let's see, inverse functions f and g are inverses of each other if you can substitute the g function into the f function and get an answer of x, and if you insert the f function into the g function, you also get an x. And the function g is written as f, and it's called f inverse. It looks like f to the -1. And this guy, we would never say, hey, this is f -1. We always call this the f inverse, the inverse function. And so here you go. This is a nice way to prove, right, or verify that these two functions, the f function and what they present as the inverse of the f function, let's check and make sure they truly are inverses of each other. So the first thing to do is to plug the inverse into the original function. So we see that we go 7 and then insert the inverse in for x. And when we solve this, we would distribute the 7. 7 times the 7th is 1. 7 times 4/7 is 4. Minus 4, and it truly, yes, check. We got x. I also have to plug the function back into the inverse. And so notice now for x, I'm going to plug in 7x minus 4. So I get 1/7, and then here comes the function, f of x. We distribute the 1/7, and you should get x minus 4/7 plus 4/7. These guys cancel, and again, check. So kind of a time-consuming way, honestly, in my opinion, to figure out that these two were inverses, but in a nice way, a nice effective way, and it's certainly a neat way to review from yesterday composition function. So why don't you go ahead here and just tell me what the inverse function is, right? The instructions also are asking if you could prove it, which if you have time, please feel free to do. But I think what's very important right now is, can you figure out the inverse of the original f of x function? So go ahead and hit pause and then hit play when you're ready. And here is the answer. So hopefully you were able to solve the inverse and got this answer. And I'm showing my work here. So the first thing I did was instead of writing f of x, I wrote y equal to. Then I switched, so highlighted in red. This is the big move, right? The inverse, you switch x with y. And then, just to be a nice guy, I'm going to clean up the equation and solve for y. So I subtracted 5, then I divided by -3. And so here is, the answer. And then, to be even nicer guy, you might want to present, and say, hey, look, I'm going to make it look even better. I'm going to write it as the inverse. So f -1 is, I shouldn't even say it, but that's what it looks like. It's the f inverse of x. And then here's the proof. I did it. Again, I didn't say you needed to, but I could take my answer, plug it back into the original function. Notice that I solved for x, and then I could plug the function into the inverse, clean that sucker up, and notice I again check, get x. So I know, if this was the only problem on a test and I wanted to make sure I was right, I could always do this as a check. Okay, so here we go. We're going to find the inverse of a power function. So a little trickier, right? The other example we did the inverse of a line, but things get a little harder when the equations get a bit more involved. So this is a parabola, 4x squared you should say, and they're asking for just the inverse when x is less than or equal to 0. And we'll talk about that a little bit more in a sec. So here, take the function. Notice we always replace f of x with y. And then here comes the big move. Bam! We switch x with y. And again, this is it. This is the key to success for inverse, that you remember switch x with y. So now we need to solve for y. And notice when I do that, first thing I'll do is divide by 4. And now you should say, hey, you need to take the square root of both sides, and we'll get plus minus. So this plus minus throws us off, and that's exactly why they said, look, let's just do it for when x is less than 0. So that will just give us, and let me pull this all the way down, right? That'll just give us the negative 1/2 x square root of x, right? Because we're defining this. And so notice here, this parabola from here on up is the parabola just for x less than 0, right? Don't forget there was a parabola here. The rest of the parabola would look like this. But if I take this and I find the inverse, I would do the negative 1/2 square root of x. And what's really nice about this graph is that hopefully you see the symmetry. This line is reflected in the red line, and it's reflected about the line y is equal to x. So the inverse and a function always reflect about. Reflect means it's a mirror image, if you will. And that's what this caption here says. So nice if we can graph a function and its inverse, we should always see this reflection. That's another way to test whether or not you found the correct inverse, right? The other method was this other previous method when we substituted it back in. So this is this is one way to check, do I have the inverse, right? And a second way would be to graph the function here in blue and its inverse in red, and notice that it's reflective about the line y is equal to x. Okay, so here is the horizontal line test. So the inverse of a function is also a function if and only if no horizontal line intersects the graph of f more than once. So if you're given here this guy is the function in question. So is this function, does its inverse also satisfy a function? And here we draw a vertical line test. We only intersect once. And so, again, if we were to figure out the inverse and graph it, it would also be a function. And notice here the inverse, this function, this parabola, its inverse would not be a function because it failed. And so this guy I can prove to you also, if I graph the inverse, it would look like this, right? And hopefully you see that reflection. See how I kind of flipped it over that line? And here you would say, no, the vertical line test would say that this is not a function. The horizontal line test kind of previews that, which is pretty nice. The inverse of this guy, by the way, I could draw that one as well. It looks like this. Oops. And so you can see, this inverse is a function. It passes the vertical line test. Let's see here. Find the inverse of a cubic function. So first of all, a cubic function is the graph of a cubic function would look like this guy here. So it's shifted up 3, and then the 1/4 kind of slows this guy down, allows us to graph 2 points off of the original here. And so to do the steps, first of all, we can determine from this graph, right? Horizontal line test shows us that the inverse will be a function. And then the steps, we'll do the exact same steps, right? We cross off the f of x, write it as y, the big switcheroo for the inverse, and then we go to solve. So they subtracted 3 from both sides. Now we're going to multiply everybody by 4, and then finally take the third root, and that is the inverse function. And it is a function, right? And we know that clearly because we can see from the original that it passes the horizontal line test. So here you go. You've got 2 problems. All you have to do is find the inverse. So we're hoping you'll find, set this equal to y, switch x with y, and solve. Notice here we've got a restriction on the domain. You can only do this for x greater than 0. And then here, the 5th root, there is no restriction. So go ahead and hit pause. And when you're ready, I'll show you the answers. And there are the answers. So I showed you my work. Let me walk you through it. So first step was to switch, get rid of the f of x and write it as y equal to. Now I switched x with y. That's the big move for inverse. Did it in red just to help you see it. And then I subtract 1, divide by 2, and then I take the 4th root. And again, that's plus minus. So because I was told only to do this for x greater than 0, right, we say, okay, forget about you, negative guy. And the final answer would be just the plus side of it. When we take the 5th root, we don't care about plus minus, so there's no restriction here. Let me walk you through the steps, though. So we took the g of x, wrote it as y equal to, switched x with y, did the big inverse move. I multiplied both sides by 32. I now take the 5th root, right? And here you could leave it like this, but hey, we know the 5th root of 32 is actually 2, so it's a better answer here that the book gave us. So well done. Hope you are still with me, and we will practice all this tomorrow in class. See you then.